So for this problem, you're looking at a whole bunch of limits and a whole bunch of function values. You have a graph. You don't have a calculator, so you can't look at these tables to figure out any of these limits. The function values, all the ones that simply say f of -3, f of -4, f of +1, f of -1, for all of those you're simply looking for the dot where the y value is. The rest of them, you're looking at the limits, what the x value is approaching. Or excuse me, what the y value is approaching as x approaches whatever it's approaching. So we'll take the first one. The limit as x approaches -4 with a little positive sign that means from the right. So imagine you're a little bug. You're walking along this graph and you're around -4. So an x value of -4, that's this x value right here. And so you're a little bug, you're starting from the right hand side of 4 and you're just walking along the graph. You're walking along the graph from -3 and you're getting to a y value to approach something. So what is your y value approaching as you walk along and walk along and walk along? Well, your y value is getting closer and closer and closer to this y value of 1. Doesn't really matter that the y value is 1. That's not what we care about. We care about what we're approaching. We're approaching a y value of 1. That's the limit. Now when we do -3, it's a different story. When we look at the limit as x approaches -3 from the right-hand side, again, you're a little bug. You're walking along this graph. You're on the right of -3. Here's where x is -3, and you're walking along from the right. So you're starting here, say at x equals -1, and you're walking along this graph, walking along this graph, walking along this graph. If we created a table of values, when x is -1, your y value is 2. When x is -2, your y value is 2. When x is -2.5, your y value is still 2. In fact, if you kept making that table on and on and on, all you'd see are y values of 2, 2, 2, 2, 2. So what are you approaching? You guessed it. You're approaching a y value of 2. Now when x approaches -3 from the left-hand side, that means you're walking along this side. And your x value is getting closer to -3. Well, your y values aren't always 2, but if we made a table of values from x equals -4 to x equals -3, as we've got highlighted, we would see these y values. The y values would be 1, and then 1.2, 1.6, 1.7, 1.8, 1.9, 1.99, etc., etc., etc. Our y values are also approaching 2, and so that's the limit as x approaches -3 from the left. Now, I don't even need a graph at this point. If my limit as x approaches -3 from the right is 2, and my limit from the left is 2, then that automatically means, from the rule we learned today, that the limit as x approaches -3 is 2. The function value, however, that has nothing to do with the limit. That's a totally different question. When we do the function value is saying, what is the y value when x is -3? And if we look, the y value when x is -3, that's where the closed dot is. Well, there is no closed dot at x equals -3. There's only an open dot there, which means that the y value at -3 does not exist or is undefined. We will always just say does not exist. For f of -4, that's asking what's the y value, where's the solid dot when x is -4? Well, that's right there. That would be a solid dot at +1. And so f of -4 is 1. Notice f of -4 is the same as the limit, whereas f of -3 is not. That's okay. They're two totally separate questions. When we go to -1, when we go to +1, as x approaches +1 from the left. So again, you're a little bug. You want to approach an x value of +1. So here x value is -1, and then we just slowly walk and walk and walk and walk to an x value of +1. We look at our y values. What are our y values getting close to? Our y values are getting closer and closer and closer to -1. And so that's the limit. The limit's -1. Coming from the right-hand side, same thing. If I'm looking from the right-hand side of 1, that's coming from here. Our x value is 3, our x value is 2, our x value is 1. We're getting closer to 1. Our y value is getting closer and closer and closer to -1. And so that's the limit. Once again, once I know the left-hand side is 1 and the right-hand side, is -1, then I get the limit as x approaches 1 automatically. That limit must also be -1. If these two match, then that means that this one has to be the same thing. f of 1 is asking where's the colored in dot. So just like we saw when we did f of negative 3, f of negative 1, the colored in dot at negative 1, isn't there. There is no colored in dot at negative 1. Since there is no colored in dot here at negative 1, our y value does not exist. Finally, when we do f of negative 1, f of negative 1 is going to work the exact same way. F of negative 1, the limit as x approaches negative 1 from the left. So again, you're a little bug. Your x value is going to get closer and closer and closer to negative 1. So your x value is negative 3, negative 2, negative 1. When your x value reaches negative 1, what is your y value getting close to? Your y value is getting close to 2. Doing negative 1 from the right-hand side, well, again, you're a little bug. You're approaching an x value of negative 1. So here, x value is positive 1, your x value is 0, your x value is negative 1. What y value are getting close to? Your y value that you're getting close to, you're getting close to a y value of negative 2. And so that is the limit as x approaches negative 1 from the right, negative 2. Now, I don't need the graph to figure out the limit as x approaches negative 1. All I need are these two pieces of information. Since the limit from the left is positive 2 and the limit from the right is negative 2, those are not the same value, so therefore, Lindsay Lohan is right, this limit does not exist, because the left-hand limit is not the same as the right-hand limit. Finally, f of negative 1. F of negative 1 is simply asking where is the colored in dot when x is negative 1. When x is negative 1, I simply look for the colored in dot. The colored in dot is way up there at x equals 2, at y equals 2, and so f of negative 1 is equal to 2. There's the limits and the function values for x equals negative 4, x equals negative 3, x equals negative 1, and x equals positive 1.